Assalamualaikum and hello everyone. In this video, we are going to present the heart failure prediction for STA108 Statistic and Probability Group Assignment. In our content, we have 4 chapters that we are going to present, which is Introduction, Methodology, Results and Interpretation, and lastly, the conclusion.
Hi, I'm going to present about Chapter 1. Chapter 1 is an introduction. Introduction have a 3 parts, which are background of study, objective, and significant. Now, let's look to the background of study. Heart failure prediction is an important task that can assist in identifying people who are at risk of developing heart failure. Heart failure occurs when the heart muscle doesn't pump blood as well as it should. When this happens, blood often back up and fluid can build up in the lungs, causing shortness of breath. Heart failure is a complicated and possibly fatal element that places a huge strain on healthcare system worldwide. The study was carried out to evaluate the association between the respondents' ejection fraction and their age. In this context of research, ejection fraction is shown percentage of blood leaving the heart at each contraction. Ejection fraction is a dependent variable for this study, while the independent variable is the respondent age. This study includes 299 people of various ages and who have ejection fraction. The respondents range in age from 14 to 95 years old. Next, the objective of this study. First, to determine the relationship between the age of the respondents and their ejection fraction, which is percentage of blood leaving the heart at each contraction. Second, to find squareness of the data, either it is squeezed to the left or squeezed to the right. Third, to determine the mean, median, and mode of respondent age and their ejection fraction. Lastly, for this part is a significance of study. The main objective of this study is to determine the association between the age respondent and their percentage of blood leaving the heart at each contraction. Research on heart failure prediction is important because of diagnosis heart illness are difficult undertaking. If we can provide a systematic prediction about a patient's heart condition, then appropriate treatment decision can be made. Heart failure is a serious, chronic illness that often worsens slowly over time. Several symptoms can occur in heart failure patients. The symptoms may develop slowly, but sometimes it can start suddenly. Heart failure can be prevented by controlling conditions like high blood pressure, diabetes, and obesity. People can also change their lifestyle with healthy lifestyle.
Now, I will talk about second chapter, which is methodology. In this chapter, it has 3 main subtopics, which are 2.1 is data description, 2.2 is graphical technique, and 2.3 is numerical technique. Okay, here is 2.1, which is data description. As you can see, this is the table of description of variables. We have 2 variables, which are independent variable and independent variable. The independent variable is age and the dependent variable is ejection fraction. The type of these 2 variables is same, which is a qualitative variable, and the level of measurement is also the same, which interval data. The next subtopic is graphical technique. For the first one, we have variable x, which is age, and the variable y is the ejection fraction. Chart that we use is box and whisker plot. For the second one, the variable x and y is the same, which are x is age and y is ejection fraction, and the chart is scatter plot. Now, the last subtopic for chapter 2, which is numerical technique. In this subtopic, we have 5 statistical techniques. Okay, the first one is measures of central tendency. We have to find the value of mean, median, and mode by using this formula. The second one is measures of dispersion. We have to find the value of variance, standard deviation, and also the range. Next, for the third technique is measures of position. The value of minimum, maximum, first, second, and also third quartile need to find. The minimum is the extreme end of line of left side. Maximum is extreme end of line of right side. Then the first quartile, we use this formula which is n plus 1 divided by 4. Second quartile, n plus 1 divided by 2. And the last one, third quartile, 3 times with n plus 1 and divided by 4. Okay, so this is the fourth and fifth technique, which are correlation analysis and regression analysis. Correlation analysis, we use these two formula to find value of person's product moment correlation coefficient, which is R. Also the value of coefficient of determination, which is R squared. And lastly, for regression analysis, we use y equals to a plus bx to find value of linear regression. Y is the value of dependent variable, a is y-intercept, b is the slope of line, and x is independent variable.
So now I will be talking about chapter 3, results and interpretation. So in data presentation in this project, data that we have seen shows that the independent variable is age, years, while the dependent variable is injection fraction, percentage. The types of variable for independent variable is a quantitative continuous variable because the age of the patient is counted by years, which is time due to the response that can be approximated to some accuracy using measuring devices. Furthermore, dependent variable is a quantitative discrete variable due to it can be measured precisely by counting. We have studied the relationship of age and injection fraction of 299 patients. Shown there from the table are several random data that we have picked. So based on the box plot that is shown there, the distribution of age years above can be concluded that the minimum value is 40, maximum value is 95, first quartile is 51, median is 60, and third quartile is 70. Moreover, this data is skewed to the right. It can be seen from the box plot that the right whisker is longer than the left whisker. Hence, that is why the data distribution is right skewness. So based on the box plot that is shown there, the distribution of the injection fraction percentage above, it can be seen that the minimum value is 14, maximum value is 80, first quartile is 30, median is 38, and third quartile is 45. Moreover, this data is skewed to the right. It can also be seen from the box plot that the right whisker is longer than the left whisker. Hence, data distribution is right skewness. So based on the scatter plot that shows the relationship between age, years, and injection fraction percentage above, it can be concluded that there is no correlation. This is because there is no one common direction to describe the relationship of the two variables.
Hence, there is no correlation between the two variables.
However, based on the Pearson product moment coefficient of correlation, or R value, R equal to 0.06, the result shows a linear positive correlation between the age and the injection fraction. Furthermore, the result shows that the strength of the correlation between the age and the injection fraction is weak. This is because R value is closer to the number 0, thus the closer the value of R to the number 0, then the weaker the correlation will be.
Now we move on to the descriptive statistic analysis. From the data that we obtain, it shows that the independent variable, which is age of the patient, and the dependent variable, which is ejection fraction, which is percentage of blood leaving the heart at each contraction. We will analyze the relationship of the data between these two variables. This involves the measure of tendency, measure of dispersion, measure of position, and the measure of skewness. Firstly, for the age table, the mean of the data is 60.83. It means that the average of people who predicted to have a heart failure is 60.83 years old. For median, it shows that the median of the age data is 60.00. It means that 50% of people who predicted to have heart failure are less than 60 years old, while another 50% are more than 60 years old. Lastly, for mode value, the value is 60.00. It shows that most people that are predicted to have heart failure is 60 years old. Next, the range value is 55.00 and the variance value is 141.486 and the standard deviation value is 11.894809. Next, for the ejection fraction table, the mean of the data is 38.08. It means that the average of ejection fraction of people who are predicted to have heart failure is 38.08%. For median, it shows that the median of the ejection fraction data is 38%. It means that 50% of ejection fraction are less than 38%, while another 50% are more than 38%. Lastly, for mode value, the value is 35.00. It shows that most people that are predicted to have heart failure has a rate of 35% of ejection fraction. Other than that, the range value is 66 and the variance value is 140.063, and lastly the standard deviation value is 11.835. Next, correlation and regression analysis. For correlation value that we have obtained, the Pearson's product moment coefficient of correlation or R value is R equals to 0.06. The result shows a linear positive correlation between the age and the ejection fraction. Also, the result shows that the strength of the correlation between the age and the ejection fraction is weak. This is because R value is closer to the number 0, then the closer number to 0, then the weaker the correlation. Moreover, R squared is equals to 0.004 is used to express the coefficient of determination, that also known as the R square value. The value indicates that 0.4% total variation of ejection fraction is determined by age, while remaining 99.6% is determined by other factors. Now, for the coefficient table, we can form a regression equation which is y equals to a plus bx, where x represents the independent variables which is the age, and y represents the dependent variable which is the ejection fraction in percentage. Besides, constant a represents the constant or the value of y-intercept which is a equals to 34.446, and other than that, b represents the value of the slope of the line which is b equals to 0.06. With the complete information that we have obtained, thus the regression equation is y equals to 34.446 plus 0.06x. In short, when age is increased by 1 year, the ejection fraction will increase by 6%. From this table, we can find that there is no relationship between the age and the ejection fraction.
Conclusion. In conclusion, the objective of this study is to identify the relationship between two variables, which are the independent and dependent variable. In this study, the independent variable is age, years, while the dependent variable is ejection fraction, percentage. Furthermore, another objective of this study is to determine the skewness, whether it is skewed to the right or skewed to the left. The result from this project data shows that the data is skewed to the right, indicating that mean has higher value compared to median and mode. And last but not least, the objective of this study is to determine the mean, median, and mode of respondent age and their ejection fraction. For the age of the respondent, mean is 60.83 years old, median is 60 years old, and lastly, mode is 60 years old. And in the other hand, for the ejection fraction, its mean is 38.08%, its median is 38%, and lastly, its mode is 35%. That's all from us. Thank you for watching.